Welcome to the AI Research Roundup. I'm Alex, and today we're looking at a paper from the Hugging Face trending list, published on June 27, 2025, so about a week ago. This paper introduces an AI system for medical diagnosis that achieves 4 times the accuracy of human physicians on a new, challenging benchmark. The paper is titled Sequential Diagnosis with Language Models, and it presents a fascinating framework for making AI a more realistic and cost-effective partner in medicine. The authors argue that most AI evaluations are too simple and don't reflect the complex, step-by-step nature of real-world diagnosis. So to see how this all works in practice, the authors provide a great example. They start with a brief case summary, a 29-year-old woman with a sore throat. Then we see the AI agent, which they call the AI Diagnostic Orchestrator, begin its work. It doesn't just guess. Instead, it asks specific questions to a gatekeeper agent, which is part of their new Sequential Diagnosis Benchmark. This benchmark is the system that provides the step-by-step patient information. The AI Diagnostic Orchestrator even shows its internal debate, like a virtual doctor panel, weighing the costs and benefits of different tests before reaching a final, accurate diagnosis. Alright, so this diagram gives us a bird's-eye view of their whole evaluation system, the Sequential Diagnosis Benchmark. At the center, you have a diagnostic agent, which could be a human doctor or an AI, trying to solve the case. It interacts with a gatekeeper agent. The gatekeeper is an AI that holds all the patient data, only releasing information when asked. This forces a step-by-step process where every test has a cost. In the end, a separate judge agent, another AI, evaluates the final diagnosis for accuracy. This whole setup is what makes the benchmark so challenging. Okay, so how does that judge agent actually decide if a diagnosis is correct? Well, this table details the 5-point Likert rubric it uses, which is essentially a standardized rating scale. It grades the final diagnosis from 1 for completely incorrect all the way up to 5 for perfect or clinically superior. What's crucial here is the nuance. For example, a score of 4 is mostly correct and wouldn't change patient management, while a 3 indicates a major error. For their final results, a score of 4 or above is considered a success. So, with that scoring system in mind, this chart plots the final results, balancing diagnostic accuracy against the total cost for each case. It shows what's called a Pareto frontier, which is just a way to visualize the best possible trade-offs. You want to be high and to the left, high accuracy for low cost. You can see the human physicians as red crosses, clustered around 20% accuracy. The other scattered dots are various off-the-shelf AI models, but that blue line at the top is the AI Diagnostic Orchestrator, creating a new, superior frontier. Building on that superior Pareto frontier we just saw, a key question is whether the performance holds up on completely new cases. This chart directly compares the results on the validation set. That's the data used to fine-tune the model, with a completely new test set. The AI Diagnostic Orchestrator's frontier, shown by the blue lines, is nearly identical for both the solid validation and dash test lines. This consistency is crucial. It proves the system has learned a generalizable strategy and isn't just memorizing answers from its training data. So, to wrap things up, the big takeaway here is that simply having a powerful AI isn't enough for complex tasks like medical diagnosis. By creating a system, the AI Diagnostic Orchestrator, that forces the AI to think step-by-step like a team of doctors, the authors achieved results that were 4 times more accurate than human physicians and much more cost-effective. This structured reasoning approach is the real breakthrough. That's all for this week's AI Research Roundup. Thanks for tuning in, and we'll see you next time.